Space-time is everything that surrounds us. But what is it really, and how can we actually visualize it? Space-time is defined as the collection of all events created by fusing physical space and real time into one single fabric. Let's explore these 4 dimensions that seem out of this world. In 1905, Albert Einstein developed the special theory of relativity. This changed how the entire universe was perceived, shifting away from the traditional understanding of space, time, and motion established by Isaac Newton. However, it wasn't until 2 years later that Einstein's mentor, the German mathematician Hermann Minkowski, formally described space-time as 4 interconnected dimensions, clarified a concept that many, at the time, found extremely difficult to accept. If we look back at the history of science, time was always seen differently than space. Newton spoke of space as a 3-dimensional stage, while time was treated as a completely separate entity. For a long time, these concepts were never linked. Space-time, therefore, is the combination of 3-dimensional physical space and time, and these 4 dimensions simply cannot be separated. This connection became clearly visible when describing relativistic motion, which involves speeds close to the speed of light. During Newton's era, and even long after, it was impossible to conduct experiments with objects moving at such massive speeds. While scientists had known since the 17th century that light moves at a finite speed, that fact didn't significantly impact the description of everyday phenomena back then. So, how did scientists figure all of this out, and why did the old theories stop fitting the reality? It actually started with the study of electricity and magnetism. These phenomena, and the equations describing them, began to look very strange when viewed from different perspectives or frames of reference. Mathematical paradoxes began to emerge, showing that these physical events didn't look the same depending on where you were observing them from. Key to understanding the entire concept of space-time is the letter c. In the world of physics, this stands for the speed of light in a vacuum. This particular c is a fundamental physical constant, and to grasp its importance, we should look at a simple example. The most crucial assumption Einstein made was that light always travels at the exact same speed, regardless of the frame of reference from which you are observing the light beam. Let's put this into perspective. If you are traveling on a train, you will measure the speed of light to be exactly c. Now, imagine you are sitting on a station platform while that train zooms past you at a hypothetical speed close to the speed of light. Even then, as an observer on the platform, you will still measure that same beam of light at the exact same speed. It doesn't matter how fast the train is moving, the speed of light remains constant for everyone. This consistency has massive consequences and leads to a series of very strange phenomena. The most famous of these is the twin paradox. This concept is already quite well known in pop culture, and interestingly, it is usually presented correctly. Imagine 2 twins. One twin stays home on Earth, while the other boards a rocket and heads out into deep space. Let's say the astronaut twin travels at nearly the speed of light for 20 years, and then spends another 20 years on the return trip. When he finally lands back on Earth, the results are shocking. The twin who stayed on Earth has aged by about 40 years. However, the twin who flew the rocket has only aged by a few years, or perhaps even just a few months. They are no longer the same age. For each of them, time literally flowed at a different rate. Now, if time flows differently for different bodies, you might ask, Why is it specifically the twin who stayed on Earth who aged more? This is not a lack of logic. Despite how much it challenges our everyday awareness, the situation is perfectly logical. The reason lies in the fact that the frames of reference for both brothers are not equivalent. Only one of the brothers remains in what is called an inertial frame. This means he is not subject to external interactions with other bodies, moves without acceleration, or remains at rest. The brother on Earth fulfills this condition. Twin who travels, however, must change his speed. He has to speed up when he starts his journey, and eventually, he has to turn his rocket around to come back home. Because of this, he is not in the same frame of reference as he was at the beginning. And this brings us to the very heart of how we understand time itself. After exploring how motion affects time, we finally arrive at the heart of the matter, the true nature of time itself. For centuries, the world believed that time flowed equally everywhere, regardless of whether you were moving or standing still. But Einstein's description of the universe changed everything, giving a completely new meaning to what time actually is. Even though we treat it as a dimension, the fourth dimension remains a profound mystery to physicists. Think about it. We can move through the 3 dimensions of space in any direction we want. We can go left, right, forward, backward, or move in loops. But in time, we are passengers on a one-way street. We are completely powerless to move backward. We can only go forward. We perceive time as something linear, a constant stream where the future becomes the now, only to instantly vanish into the past. But in reality, Einstein showed it as a dimension much like the others. To visualize this, scientists use space-time diagrams to map the trajectories of objects. Imagine an object that is perfectly still in space. On a space-time diagram, it still moves, creating a straight line parallel to the time axis. This is because even if it's not moving through a room, it is constantly moving through time. If that object starts to move through space, its path becomes a diagonal line, shifting across both space and time axes simultaneously. But then, Einstein introduced an even bigger revolution: general relativity. This theory describes how gravity itself fits into the fabric of reality. It turns out that energy and mass placed within space-time can actually warp and distort it. You might have heard people say that space is curved, but that isn't entirely accurate. It is space-time, the combination of all 4 dimensions, that is being bent. This curvature is exactly what we experience as gravity. Before Einstein, Isaac Newton could describe how gravity worked with great precision. We still use his equations in schools and for advanced calculations today because they are incredibly accurate. But Newton couldn't explain the nature of gravity. He couldn't say why it existed in the first place. Einstein revealed that gravity is actually an apparent effect. It is the result of objects simply taking the shortest possible path through a curved 4-dimensional reality. Physics has a way of surprising us. The world we inhabit isn't quite what it seems on the surface. It is a place that is often difficult to accept, yet it is perfectly logical. For over 100 years, not a single person has been able to prove Einstein wrong. Every experiment and every observation has only confirmed his genius. We may be powerless against the flow of the 4th dimension, but thanks to these theories, we finally understand the beautiful architecture of the universe.